Welcome to the Explainer. You know, we've all seen those cool AI demos, right? But have you ever wondered what it really takes to get one of those things out of the lab and into the real world? Today, we're going to peel back the layers of a production-grade autonomous agent called Clawbot, and you'll see the incredible engineering that separates a fun toy from a tool you can actually trust. And let's just start with this quote because it absolutely nails the entire point of our discussion today. The story we're often sold is super simple. Just take a large language model, give it a few tools, and bam, you have an agent. But the second you try to build something that has to work reliably, that simple idea just shatters. And this slide right here shows you that gap perfectly. I mean, look at the left. That's the dream, right? A clean, simple LLM plugs into tools. But on the right, well, that's the messy, beautiful reality. A real production system is this whole intricate dance of components that have to manage stateful, multi-step thinking, orchestrate a bunch of different tools, and, crucially, build a memory so it can actually learn from what it does.
So, here's our game plan. First, we're going to blow up that LLM plus tools illusion. Then, we'll get to the heart of the system, the cognitive control plane. After that, we'll see how it separates thinking from doing, how it builds a real memory, and finally, we'll look at the production-ready layers that most people forget about. Let's get into it.
All right, let's dive right into that first big idea, the illusion. To really get why that simple model doesn't work, we need to look at the high-level blueprint of a real agent. Let's follow a single request from the moment the user types it in all the way to the final answer. Okay, so a user request comes in, hits an API gateway, and gets sent over to the orchestrator. Think of that as the planner. The orchestrator then uses an LLM for the actual reasoning, which might suggest, hey, I should use a tool. The tool executor layer then handles that, and the output goes back to the user. But here's the really smart part. Each of these components is its own independently scalable service. This is a game changer. It means a tool that's taking forever to run can't crash the entire thinking process. So now, let's zoom in on the most important piece we just saw, the orchestrator. This is the cognitive control plane. It's the system's brain. And I want you to notice something really important here. The brain is explicitly not the LLM. It's the component that actually manages the LLM. Yeah, you can think of the orchestrator as the adult in the room. The LLM is the creative, brilliant, but sometimes chaotic genius, and the orchestrator is the one that gives it structure. It manages the core think, act, observe loop. It decides when to call tools. It handles what to do when things inevitably break. It enforces safety rules, and it even keeps track of a budget, so the agent doesn't just run wild. This is where the reliability comes from. And instead of just chaining a bunch of prompts together and hoping for the best, Clawbot uses what's called a deterministic state machine, like you see here. The system moves through these clear, predictable states. It initializes, it plans, it selects a tool, it executes the tool, it observes the outcome, and then it's done. Why does this matter? Because it makes every single run predictable, way easier to debug when something goes wrong, and 100% reproducible. Now this is a concept that gets missed all the time in academic papers, but is absolutely critical in the real world: workflow durability. So, what happens if your agent is halfway through a 10-step task and the server crashes? Does it just forget everything? Clawbot is built as a recoverable workflow. That means if it fails, it can pick right back up where it left off. That's a must-have for any serious system. Okay, next up, let's talk about how Clawbot creates this really clean separation between the act of thinking, which is done by the LLM, and the act of doing, which is the tool actually executing in the real world. You see, you can't just let an LLM ramble on and hope it says the right command. That is a recipe for absolute chaos. So to keep things under control, Clawbot forces the LLM to fill out a strict form, in this case, a JSON schema. It has to write down its thought process, the exact action it wants to take, and the specific inputs for that action. This stops the model from just making stuff up and guarantees the system always understands what it's being asked to do. And check this out. This is just plain smart engineering. You don't always need to use a sledgehammer to crack a nut, right? You don't need your biggest, most expensive model for every little task. Clawbot uses a clever routing strategy. It'll use a powerhouse model like GPT-4 for the final user-facing answer. But for an internal step, like just selecting which tool to use, a smaller, faster, cheaper model like Mistral is perfect. It's all about using the right tool for the job. The whole tool layer runs on this simple, super powerful principle. The LLM proposes, but the system disposes. The model suggests an action, but before anything actually happens, the system validates that proposal. Does it fit the rules? Are the inputs correct? Only then does it execute. And on top of that, every single tool is wrapped in its own little fortress of reliability with validation, logging, and timeout protection.
So think about it. An agent that can't remember anything is just a glorified calculator. It can't learn, it can't improve, it can't really be called autonomous. So let's dig into how Clawbot builds a persistent cognitive layer, in other words, how it remembers. Clawbot's memory system is actually a lot like our own brains. It's got 3 distinct layers. First, there's short-term memory. That's basically just the context of the current conversation. Then there's long-term semantic memory, where it stores knowledge in a vector database, allowing it to retrieve ideas based on meaning, not just keywords. And finally, and this is so important, it has episodic memory, a detailed log of past tasks, what worked and what didn't. That is the foundation for genuine learning. All right, now we're getting to the layers that truly separate the weekend projects from the production systems. This is the stuff that gets glossed over in demos, but is absolutely make or break in the real world: observability and reliability. How do you know if your agent is actually working well, and what do you do when it breaks? Because trust me, it will break.
The old engineering mantra is you can't improve what you can't measure. And that is gospel here. You can't fly blind. Clawbot is designed from the ground up to track everything. How many tokens is it burning through? Which tools are getting called the most? Where are the errors popping up? Is its memory even helping? Without these metrics, you're just guessing.
And a metric like cognitive latency is a perfect example. It's a fancy way of asking, where is the agent spending its time? Is it thinking too long, or are its tools just slow? And with a chart like this, you know instantly. We can see tool time is the biggest bottleneck here. Now the engineers know exactly where to focus their efforts to make the whole system faster. A truly robust system has to assume failure is just a normal part of the process. It can't just throw up its hands and crash. Clawbot has these practical, battle-tested strategies built right in. If the tool times out, it can retry, maybe waiting a little longer each time. That's called backoff. If the LLM spits out some nonsense JSON, it can try again, or even scrap its current plan and come up with a whole new one. That's what real resilience looks like.
Okay, so let's bring all these pieces back together. We've talked about the orchestrator, the state machine, the layered memory, the deep observability. By now, it should be crystal clear that what we're looking at is so much more than just a simple wrapper around an LLM prompt.
So no, this is not just an LLM with a few plugins. Clawbot is a complete, distributed cognitive system. It's a stateful execution engine, it's a sophisticated tool orchestration framework, it's a cognitive layer with a real persistent memory. And maybe most importantly, it's an architecture that was built from day one to be measured, to be understood, and to be improved.
And this right here is the key takeaway of this whole thing. Real, useful autonomy doesn't just magically pop out of a more powerful model. It emerges from the thoughtful, robust, systems-level architecture you build around that model. It's this combination of structured reasoning, predictable tools, persistent memory, and recoverable workflows that actually gets you to true autonomy.
So after seeing all the complex machinery that goes into a system like this, it kind of leads you to a final, pretty provocative question, doesn't it? Where is the next big wave of innovation in this field really going to come from?
And the argument here is a powerful one. The most exciting breakthroughs probably aren't going to come from just making our base models a few percentage points better. No, they're going to come from designing more sophisticated, more reliable, and more intelligent agent architectures, the systems layer, just like the one we've explored today with Clawbot. That is where the future is being built.